This is the 13th video of the PreventSARS3 Project video series. Our objective is to develop nanomaterials against these pandemics, so you can support this project. This video will focus on the putative engineered nature of the SARS2 Furin Cleavage Site. So this is the spike protein genome. This is a very critical capacity for SARS coronavirus 2, because only MERS has this capacity in previous human pathogenic coronavirus. As you can see, this insert, the purple, doesn't exist in the original or the parent bat virus. But if you look at the rest of the area, for example, there is no amino acid substitutions, no inserts, no mutations, nothing. So this itself is very artificial. And then the other important thing, after millions of infections in the clinics, thousands of sequences, we do not see any other recombination, and this is not this is also not fitting to the recombination model of the overall coronaviruses. So if I may give some more in-depth background to what does this furin do, furin protease do. It's a long protein, it's abundant on the surface. So the SARS2 taking advantage of this long protein. So it's using itself to speed up its entry into the cells. But as I mentioned in the previous videos, the receptor binding domain is not a positive selection site, but a mutation happened with high frequency in SARS2 in Europe and North America, because the people and this mutation D614G substitution is a bit specific to European and North American people with they have European heritage, and this strain, this mutant, gained the capacity to use serine protease, and this protease, specific protease, it's using with this mutation, very abundant in North European or European people and North American people. So this is a drawing of a spike protein of the SARS-2 coronavirus. This is the area, those are the areas, this is the sialic acid binding domain. So this is the first contact area, the number one, the first area. And this is the receptor binding domain over the top of the protein. And this is docking to ACE2 protein. This is interacting with surface sialic acid. And the furin is cutting, splitting, cleaving the protein into two. So the whole virus with the rest of it fold enter inside the cell through this direction. So how this furin cleavage capacity was gained by coronavirus? As I showed you on the sequence, 12 amino acid inserts and PRR amino acid sequence is furin protein binding area. So if this is something, a habit in SARS-2, we have to see more recombinations like this, more inserts. But this is not a pattern in the clinical isolates, and this is suggesting this is an engineered insert. So the coronaviruses has a model. It's called as template switching or copy choice model. In this model, the replication of the coronavirus in the host, in human cells or in other cells, goes on here and stop. And then this section, this whole area is in the cytosol. So an insert taking place, and then this area starts to replicate and goes on. So that's a hot spot of recombination. The recombinations are taking place with this model. So how this insert happened? If this happened randomly, we have to see the same insert, same pattern of inserts in the clinical isolates. We do not. Therefore it could be intentionally genetically insert, because this is according to template switch model. It's not something natural. So the important questions rising if this is a natural virus, why we don't see this stops in the genome of SARS-2? Why that doesn't happen? And also why we don't see this in other SARS-2, other SARS virus, in the lineage B betacoronaviruses. This is not happening in this group of coronaviruses with common ancestor, except SARS-2. How this is possible if this is not engineered?